Hello everyone, I'm Zengrong. Today I will be presenting a comfort feedback method for remote fitting. At present, e-commerce has become a part of people's daily life. And since the garment is necessary for people's lives, garment e-commerce occupies an important proportion in the West e-commerce market and the garment retail industry. However, the lack of fitting process in garment e-commerce makes consumers often buy unsuitable clothes, which leads to higher return rates and operating costs. The remote fitting method based on the fitting robot can solve the above problem. The fitting robot is a form-changing robot, and this is a fitting robot designed by our team. It can simulate the body shape of different consumers and replace them to try on the clothes. The fitting results will be fed back to the consumers as a reference to improve the efficiency of online shopping or online customization. Since the comfort of clothing is one of the main factors in determining whether a garment fits, so it is necessary to obtain the comfort information of remote fitting. Among the both studies about fitting robots, only Fitbot's research includes the acquisition of fitting results, but in the form of pictures. Therefore, our purpose is to design a comfort feedback method to get and feedback the comfort information based on a fitting robot. Clothing comfort includes three elements. Since we mainly want to solve the problem of unsuitable clothing size, this work mainly focuses on pressure comfort. Therefore, to make the remote fitting results more accurate and effective, we designed a comfort feedback method based on the fitting robot. Figure 1 shows the application flow of this method. Firstly, the pressure measuring device collects the pressure values from the critical positions. Then the pressure are transformed into comfort information by using the converter model. Finally, the comfort information is fed back to consumers through the interface. The pressure measuring device mainly includes a controller, certain pressure sensors, and certain analog amplifier modules. We selected certain measuring positions with higher comfort requirements according to the results of questionnaires from female consumers. We collected the comfort feeling of 27 female subjects, and according to the comfort range of most subjects, we set the relationship between the pressure range and the comfort levels. And according to the current study of color emotion and daily life experience, we set the relationship between colors and the comfort levels. Based on the both relationships, we established a preliminary comfort conversion model as shown in this figure. The transformed comfort information will be fed back to the interface. When one position's comfort level is too tight, the interface will display a warning message. The two figures on the left side show the comfort information of two customized dresses by using this method. The comparison result shows that in 21 out of 26 positions, the subjective feelings are consistent with the comfort levels. It preliminarily demonstrates that this method is effective. In summary, we designed a comfort feedback method based on the fitting robot. It is used to obtain, convert, and feedback the comfort information for remote fitting. The results preliminarily show the effectiveness of this method, but there are still many limitations in this work. For example, the amount of data collected for establishing the conversion model is not large enough, and we also need to test more users and more clothes of different styles and materials to ensure this method's stability. And we will do much work to improve it in the future. That's all. Thank you.